And the last part of 1.3 is a theorem that's called the squeeze theorem. This one's special enough to have its own name. This says that if h of x is less than or equal to f of x is less than or equal to g of x for all x in an open interval containing c, except possibly at c itself, and if the limit as h of x as x approaches c is L, and the limit as x approaches c of g of x is also L, then the limit as x approaches c of f of x exists and is also equal to L. So here's what this looks like graphically, and just for an example. So if this is my coordinate plane, and let's say we have a function g of x that looks something like this, and let's say we have a function h of x which looks something like this. Okay? And those are kind of my upper and lower bounds if you want to think of them that way. Let's say that we have a function f of x, and we don't know exactly what it looks like, but we do know that for the entire domain of the function, f of x is between those two functions g and h, like so. Now, if at the same c, h of x and g of x are both going towards the same point, so they're both approaching the same limit L, and we know that f of x is in between those 2 points at any given time, less than or equal to, so they could be the same at that point, then you could see the squeeze here. It's like you're taking taking your fingers and squeezing the curves, and you're squeezing that red squiggly f line in the middle. So in this case, the limit as x approaches c of f of x is equal to the limit as x approaches c of g of x and the limit as x approaches c of h of x. So sometimes this can be a very useful approach to take if you know two bounding functions and you know that their limit at c, you can figure out the limit of f of x at c. Now these two limits are what we call special trig limits. They come from the squeeze theorem. Now these two limits are direct consequences of the squeeze theorem with a little bit of trig work. I'm not going to go into the details of how you use the squeeze theorem to get these two limits, but that's where they come from. But you can use them to evaluate other limits. So for example, if you have the limit as x approaches 0 of sine of 6x divided by x. So one way that you can think about this is the variable doesn't have to be an x for this to be true as long as all three of these variables are the same. So we can replace them all with a u, and that would still be true. So this is one way that you could think of it. So if we let u be equal to 6x, as x approaches 0, so as x gets tinier and tinier and tinier and tinier, what happens if you take a number that's approaching 0 and you multiply it by 6? Well, that number is still going to approach 0, it might just be a little bit slower. So we can say that as x approaches 0, 6x is also approaching 0. And we can do the following. So I've got sine of 6x divided by x. I would like to have a u here. I would like to also have a u in this portion right here. So I need a 6 on the bottom. I'm going to multiply by 6 over 6. Again, this is just like multiplying by a 1. And I'm going to take this 6 and bring it out front, because I know I can move a constant out front of the limit. And I'm going to take this 6 and move it here. So I've got 6 times the limit of sine of 6x over 6x. And we said that the limit as x approaches 0 is basically the same thing as the limit as 6x approaches 0, because they're both going to 0. So this is now 6 times the limit as u approaches 0 of sine of u over u. So this is 6 times 1, which is 6. So the answer to this limit is 6. I do want to caution you, because a common mistake that students make is they take the limit as x approaches 0 of sine of 6x over x, and they'll try to take this 6 and bring it out front. That's a big no. You do not want to do that. If a constant or anything is in the parentheses or in the argument of sine, it's the thing that's being plugged into sine or cosine, you cannot touch it. It's stuck there. There's no way short of a trig function or a trig identity that you can change that. So just using algebra, you cannot bring that number out. You have to go through it using this process.